Okay, back here for problem 11 on worksheet 2.5. Another algebraic, and they tell me that ST and SR are congruent and QR and SR are congruent. So I can show these are equal. That'll help me set up an equality. So let's go ahead and state my given. The segments are congruent. And that's given. And that means that QR and ST are congruent. So ST is congruent to QR. That's the transitive property of congruence. Let me see. If A is equal to B and B is equal or congruent to C, then A is congruent to C. So there we've got that. Now we can set up our equality. Length ST is equal to length QR. That's our definition of congruent segments. And let me see. We can substitute in. So ST is 5, 3x minus 2. And QR is x plus 4. Go ahead and distribute. 15x minus 10 equals x plus 4. So we substituted here for equality. We did the distributive property. And let's go ahead and subtract x from both sides. Let's go ahead and add 10 to both sides. And let's go ahead and have step 8 here. We'll divide by 14. And that gives us 1, and that's the division property of equality. Remember, for an algebraic, go back and check your answer. So 1 plus 4 is 5. 3 times 5, or 3 times 1 is 3, minus 2 is 1. So 5 times 1 is also 5. Check. Okay, number 12, another algebraic. XY and WX are congruent. YZ and WX are congruent. So again, 3 more congruent segments. If I can show these two lengths are equal, then I could set up an equality. So let's go ahead. This one looks a lot like the last one. And again, I want XY and YZ to be equal, XY and YZ. So XY is congruent to YZ because of the transitive. And that means that length XY is equal to length YZ. That's because of definition of congruent segments. And then we can substitute in. We've got 4x plus 3 equals 9x minus 12. That's just substitution property. Subtract 9x from both sides. And that's just subtraction property. Subtract 3 from both sides. Divide by -5. Check your answer. So 4 times 3, 12, plus 3 is 15. And 9 times 3 is 18. Oh, let's see, I'm getting confused. 9 times 3 is 27. 27 minus 12 is 15. So my work checks. And we'll go on to next problem. Ooh, this one looks complicated. I wonder if it is or not. So we'll start with our diagram. We'll start with our given. UV is congruent to XY, so those two are equal. VW, WX, VW and WX they're congruent, and WX and YZ. So I've got 1, 2, 3 congruent segments and these two that are congruent. And then we want to show that UW is congruent to XZ. Okay, so if it's got one of the two congruent segments are added together to give me the bigger segment, so maybe that's how I can go about proving that. So UV is congruent to XY, and VW is congruent to WX, and WX is congruent to YZ. That's all given. And the segments that I'm interested in here, okay, it looks like UV and XY, those are two that I need, and I also need VW and YZ. VW and YZ. So let's say that VW is congruent to YZ. That's a transitive property. And now I can say that the lengths are all equal, so UV equals XY and VW equals YZ. And that's because of the definition of congruent segments. And since these are equals and these are equals, if I add them up, I'll have equals. So UV plus VW equals XY plus YZ. And that's the addition property of equality. Alright, so we've proved that these two things added together, but I want to show how do I know that UV plus VW equals UW, which is what I'm interested in. How about using the segment addition property? So UW equals UV plus VW, and XZ equals XY plus YZ. So that's just a segment addition postulate. And so we've got this and we've got this. I could substitute in and show that UW equals XZ. And if the lengths are equal, then the segments are congruent. And that's because of the definition of congruent segments. Alright, that one took a couple steps and a little bit of work, but there we go.